Okay, I guess we'll keep moving in the interest of time, I suppose. And actually, just to pick up on a couple of points that Alan and the guys were talking about there, and it's kind of, I'm going to start with where I'm due to finish, but just because it's relevant in terms of the platform. And where we've seen, I suppose, the use of the platform is the ability to leverage the data, to extract that data and actually use it for multiple purposes. And one of the things that we're doing is we're starting to tie in manufacturers' information and feeding that back into the design process. Again, I think it's quite a hot topic. Obviously, Rhiannon was talking about that earlier on, and there's a few others talking about it. So I'll come back around to that. You know, obviously with David and the guys, we're looking at a very macro view of things, and we're going to just get a little bit micro in terms of value-added tools. And I think what we've seen in the industry in the last 5 years, from our own experience, is companies, particularly in Ireland and the UK to a lesser extent, but certainly battling to get to that kind of level 2 point. Where I think there's a really strong theme in the conference today about those kind of beyond level 2 points in terms of value add and how you can actually, I suppose, leverage information and leverage all the data that's being provided through this process into something that means different things to different people. To introduce myself, David Palmer is my name. I'm the CEO and founder of FenestraPro. We're a technology company based out of Dublin. That's where our development headquarters are, but our main market in the last while has been predominantly in the US, is where we've been most successful. Our core product, FenestraPro Premium, is a facade design tool that's predominantly for building designers, architects, facade engineers, and it's very much focused around it. It's an early stage design tool as opposed to an analysis tool. So what it does is it actually guides the architect design the optimal solution. We strip out a lot of the complexities that you would normally see with end-energy analysis, and we focus on the performance of the facade based on kind of thermal performance, passive solar heat gain, and natural daylight. And what we're trying to do is provide a tool that gives an architect a balanced approach to producing and optimizing his design, which is predominantly around the facade, at that earliest point in the design process. Where we're starting to move to with the platform, as I alluded to a moment ago, is that we're starting to actually pull in manufacturers' data. So obviously, for example, taking glass, which is where we're very much focused on, there's a lot of information there that feeds into how a building is going to perform in terms of passive solar heat gain, natural daylight, and thermal performance. So a lot of that data is available from the manufacturers, but it hasn't really been, and we've been working with Autodesk to feed that information into a process that will actually output a performance based on material selection as much as anything else. So we've been around for about 5 years. We really launched our kind of first version of our product last year. We've over 50 clients, including the top 5 architectural firms in the world. So as an Irish company, it's kind of nice to be able to announce that level of success with the software that we're developing. We're very close with Autodesk, although we're not completely aligned with Autodesk, but we are working closely with them in terms of our product development. And I mentioned there about how we're bringing data into Revit through a platform, but also in terms of sales and marketing support. And as I said, we've had good success with that in the US. And we're currently developing that platform that's connecting energy efficient design with a streamlined fabrication process. So again, it's how we extract the data from the authoring model, in the sense from the design, and feed that into the construction, but initially into the fabrication process, particularly when it comes to windows. So I mentioned FenestraPro. We're a facade design tool focusing very much energy efficiency and optimizing the design of the process from the earliest point in the process. We're an add-in for Revit predominantly. We are doing other stuff with the platform now, but as a Revit add-in, it gives us the opportunity to read directly from and write directly back to the actual building information model. Using FenestraPro and giving architects the tools to understand those performance criteria from that early point in the process, really effectively eliminates that late stage redesign when the mechanical engineer starts looking at the impact that the facade performance is having on the building performance, and looking to change various aspects. And that could be introducing shading, or it could be changing the glass type. But by eliminating that requirement for late stage redesign as a result of issues that the engineer is identifying, and giving the architect the tool to understand the performance implications of his design, it effectively improves their design process by around 30% by eliminating the requirement for redesign. One of the things that we've noticed with our customer base is that it's kind of that softer benefit in terms of it enables the architect to maintain a certain amount of control over the aesthetic. And as an architect, I'm comfortable saying that we're an egotistical bunch, and we like to kind of be in control, particularly when it comes to the design. And FenestraPro actually provides the tools that make that really easy from their perspective. We fit in with international best practice in terms of BREEAM and LEED, but also in terms of local regulations, all the way down to Part L or some of the US standards that we've introduced into the software. As I said, we've had some really good success, particularly in the US market, where they're slightly ahead of the curve in terms of they're looking at these value-add tools. And we've some great customers, the likes of Gensler, Acon, SOM. There is an Irish customer there, O'Mahony Pike. We do a bit in the Nordics. So we've had good, I suppose, success in delivering this solution to multiple countries at this stage. And the way we tend to look at this, we look at how we, and we've spent the last 4 or 5 years working this in terms of how we map our value add points within the design process to the design and build process in terms of that early stage, establishing glass to wall ratio, moving into understanding where's the best place to put the glass, and if you have the glass at a particular orientation, what sort of glass should it be to control your heat gain and maximize daylight. So we kind of look to map that process against the design and build process itself. I know this is cheating. I know the lads at Bluebeam were using a live demo. I'm going to go with a video if that's all right with everybody, just to keep it tight, because there is a lot of functionality in FenestraPro, and I was told last night that if I ended up doing a live demo, I'll probably go for about an hour at least, to kind of show all the bits of functionality. So as I mentioned, we're a design tool within Revit. We operate within the conceptual design stages, but also in the detailed design stages. We enable the user to kind of set the benchmark in terms of those performance criteria. At a very simple level, FenestraPro is a dashboard that kind of highlights where you are in relation to your thermal performance, your passive solar heat gain, and the natural daylight in the building. And then as you start to kind of configure your building and establish your various parameters in terms of, for example, glass to wall ratio, we automatically write that back to the Revit model itself, or the BIM model itself. And you'll see here where we've got various points in terms of how we control that heat gain by looking at alternative glass types, reducing the percentage glazing, introducing shading, and again you can see that automatically generating the shading as you look at that in terms of how it's calculating on your heat gain and the impact that has on your daylight. So that's very much on the early stage. And the thing about the conceptual model is it doesn't hold the data in Revit. So what FenestraPro does, it actually manages that data for you within FenestraPro, and you can produce multiple reports at that early stage. And then once you've kind of established what that let's say optimized configuration, percentage glazing, where's the best place to put the glass and so on, and you move into the detail model, what we do, we have this concept of generative design, whereby you can use performance benchmarks to actually drive the design. So in this case, we're setting a heat gain for each of the spaces, and from there we have a rough configuration of our window types, as it is in this case, and then you can start to look at how that will look on the building, and once you're happy with the configuration, then FenestraPro automatically writes that back to the model as a selected glass type based on the performance, and you can get quite granular on that. Within that as well, we provide ways of navigating through the facade, through each surfaces within the facade, and how we write that back then to the building information model in terms of how we create our own groups so we can actually manage that around. One of the things that we do is to produce, again, this theme that seems to be today very much around data. So, there's a lot of data being produced in the background within FenestraPro. We have hourly heat gain, daily, monthly, weekly. We have all our daylighting configurations and calculations on the back of that. We understand the implications of material selection. And we ultimately produce that into a report that provides a level of, I suppose, flexibility in terms of how that data is used by the architect. So we can, at any point in the process, and again, we're supporting that iterative process of design. But at any point in the process, you can extract the data and capture a snapshot of a point in time. And it gets quite granular. Like I said, we have a lot of data in the system, but we only present a certain amount of data where you can look at it on a facade or surface by surface basis as you feed that into the process. And again, what we've seen with our customer base is that it enables a much more informed conversation with the engineers when it comes to that kind of late stage analysis. I mentioned earlier on we're starting to feed some data, manufacturers' data into the process as well. We're just about to launch our kind of next version of our product, which is FenestraPro Link, and that's the principle behind that is if you think about the construction's XML file within Revit, it's static, it's probably 10 years old, the data is all out of date. So what we've been commissioned by Autodesk to do is actually provide that live link to a database online where we can start feeding manufacturers' information. And the manufacturer's information that we're looking at really is around the performance characteristics. So taking glass, for example, if you look at those kind of key performance drivers in relation to what you're considering when you're selecting glass. And this is where I suppose that those BIM processes have fed into that level of understanding in terms of material selection. So within that, you can look at what materials you have selected the Revit model. You can go online and then you can start to kind of filter and search through alternative material types. FenestraPro can actually is intelligent enough that, you know, I don't like to use the AI term, but we can actually start, you know, limiting your choice of selection to based on what you're trying to achieve from a performance point of view. I mentioned that the you know, the XML file within Revit is quite static, it's hard to change, the data is locked in, it's old data, and what we've done is we've actually just linked that into that cloud database that makes that searching from alternative material selection, particularly glass type, because that's where we're very much focused at the moment, and how we feed that back into the overall process. So with the glazing, we're able to look at various characteristics. From those characteristics, we're also looking at, in addition to glazing, we're also looking at systems in terms of how we automatically generate systems and glass control, and how we can, I suppose, automate the scheduling of glazing types, and that feeds into the fabrication process. Just in terms of, I can see everyone's kind of shifting towards the lunch, so I'm just going to finish up, and again, to finish where I started when we started talking about the platform and how we extract data and present that data online. So, you know, what that has enabled us to do, and we're working very closely with a number of leading manufacturers, is how we extract that BIM data into the platform, and then how we actually configure and automate the creation of schedules. So from a glass manufacturer's point of view, we can look at the double glazed unit, what goes to make those up, and how those various differences between your inner pane and your outer pane, and that automates that estimating and scheduling, and that feeds into the fabrication and procurement process. So that's where we're kind of moving towards, and hopefully I've given you a taste of that, more on a micro level than a macro level, as Dave covered earlier on. Happy to take any questions now, or you can come visit us for more information on stand 28, hidden around the back of the main stage.
Could I ask you, just mentioning manufacturers' data, how are the manufacturers uniquely identifying their products to you?
So again, because we're very much focused on performance criteria, they see it as an opportunity to present their data based on their performance. So again, a lot of the manufacturers would have, for example, solar control glass that can reduce your heat gain by up to 80-90% in some instances, but yet they have very high, the visible light transmittance is high, so your daylight levels remain quite reasonable, as opposed to having a tint glass, which, you know, will reduce your heat but bring down your daylight. So those kind of criteria, it makes sense from a glazing manufacturer's point of view to make that information available, so that makes the selection of their better materials, and by the way, more expensive materials very often, more logical from an architect's specification.
But how do you know in 3 months' time when you're trying to buy more material for your building, or the same building, that you're buying the same product?
Well, that's more, yeah, so on the procurement side, that's where I suppose the tagging of the data. So again, you're trying to make sure you get the same glass type on a rebuy 3 months later, as you described. And really what we're doing is we're providing the tools to make sure that the performance level doesn't dissipate, and that's where we're going to focus.
So you're working on the characteristics rather than tagging.
Characteristics, but also tagging the glass with that detailed specification and the characteristics that come with that. So if you look at a glass spec, you know, you typically have your solar heat gain coefficient, your visible light transmittance, your thermal performance values that are inherent. And what we're doing is we're one of the first companies to actually take that data and logically apply it to a model in a way that, you know, that's intelligent, for want of a better description.
Would it be fair to say that this process is more on the design side, and the procurement really happens downstream?
Yeah. So and again, what we're early on the fabrication workflows that we're working with, but again, it's coming from a desire from the manufacturers. So what you're seeing now is manufacturers kind of, I don't want to say like rabbits in a headlight, but they're trying to figure out, you know, what BIM processes mean to, and digital design technologies mean to them. And you know, we've been lucky to engage with some of the leading glass manufacturers, and that's kind of led us into the fabrication piece, and that's where we're headed. At the moment, it's a design tool for architects, and that's where that kind of gives you an idea of that.
David, there was some talk earlier on in the plenary session about the gap between, you know, predictive analysis and actual building performance.
We've actually.
Is that something you're looking at?
I heard that comment. I think Anna was asking a question earlier on about that. I think there is an element of that, because I think from a building performance point of view, when you look at overall energy calculation, there's so many characteristics that feed into it. And as an architect, when I was in practice, and this is where we kind of conceptualized FenestraPro, all those kind of various, how many people are in the building, what boiler, what HVAC system you're using, architects are not interested in that. So by stripping out those complexities and focusing on the facade performance, and we use a database called Meteornorm, which is all it's basically a global database of weather information. And the calculation methods that we use are not, we haven't reinvented them. We're using CitA and we're using ASHRAE calculation methods. So we don't have that that disconnect between the inaccuracy and the end energy use, because we don't do end energy calculation. And I think what you're seeing, and our experience as architects, but also with FenestraPro over the past few years, is that a lot of people use end energy analysis calculation tools as a benchmark. So they'll establish a benchmark with their initial design, they'll make their design changes, and they'll benchmark it against the original. Is it get better or is it getting worse? And so what actually happens is you've got this iterative design process that, you know, adds a lot of time. You know, I talked about 30% design improvement, but that kind of iterative design process is time consuming, it's expensive, and if there's an engineer involved, when you're going back and forth between an engineer, the time really becomes an issue. So to answer your question, yeah, we're perfectly accurate in all our calculations. Great, thanks for your time.
Thank you. Thank you very much.